So, once again, welcome. Last time, please don't clutter up the aisle. You there, particularly don't sit there. We'll get in large trouble with the fire department, so we definitely don't want this. There's still empty seats back there. Do you see them? Just please take them. So, if you're like me, you had some bad days this year when all the Fedora and SUSE and Novell guys picked on you for always propagating Debian. Now, the background of all that happens will now be presented by Luciano and Maximiliano, who came over from Argentina, particularly to talk to you. So give them a warm welcome.
Hi, I'm Maximiliano, he's Luciano. Well, we're going to talk about the bug in Debian's OpenSSL. Okay, I guess everybody knows what a PRNG is, but for those who don't, it's a predictable random number generator, okay? Okay, then I'll start talking with a brief introduction. When this bug was introduced in OpenSSL and what the consequences were, and then Luciano will show a live demo with some exploitation techniques, and maybe even how to conquer the universe. This bug, which affected OpenSSL, the random number generator, was introduced 2 years ago due to a Debian-specific patch. So it's a Debian-specific bug and remained undiscovered for 2 years, almost exactly 2 years until Luciano discovered this. And it was published on May 2008. This bug affects the underlying library of OpenSSL, which is libssl, and every package, every program which links against this library. It not only affects Debian, but any other distribution which relies on Debian, such as Ubuntu, for example. The consequence, the main consequence, is that any cryptographic material may becomes guessable very easily. When we need a random number, we can see the output, the random output, as a random stream. And if we want to guess what the next output will be, in this case, we just need to know very low information. In this case, the entropy, the key space, is reduced to just 15 bits. And it also, the random output also depends on the architecture and endianness, whether it is 32 or 64 bits, and little or big endian, and of course in the internal state of the generator. As a consequence, the result is that any cryptographic material is guessable. You can see in this, for example, all these cryptographic schemes. They all may be, or in fact they are affected. Here are some of the affected packages. For example, openssh, openvpn, Tor, Firefox, for example, or is not included. It's not affected because it uses its own crypto suite. Well, how this bug was introduced 2 years ago It all started when a Debian user submitted a bug to the Debian bug tracking system, where he was complaining about some uninitialized variables, which were, he was getting a lot of warnings when debugging his own programs, which linked with libssl, and he was using a debugger called Bygreen. We'll see what he was complaining about. Thank you. Hola. Hi.
Hello.
Hello. Here we have a small program. It just gets a number of bytes, of random bytes from OpenSSL into the buffer and then prints it on the screen. It links with OpenSSL library. Now we run it. And we get random output every time we run it. Okay. What we want to see is what happened 2 years ago when the bug was discovered, this bug. So what we're going to do, we're linking against the original SSL library and running this little program with the debugger, which is Bygreen. It checks for uninitialized memory, and we can see a lot of warnings, almost 100 errors. So let's remember that it was just in a very, very small program. There are no uninitialized variables here, so the problem lies inside the OpenSSL library. Gracias. Thank you. So the Debian maintainer, he analyzed the source code and identified 2 problematic lines, which are those line 274 and 467, which are syntactically identical, but of course they're in different contexts, they're in different functions. What these lines are doing is adding some amount of entropy into the random number generator state. Take a look at the second line, which is enclosed by this conditional compilation macro, which is related to Purify, which is another debugger which resembles very closely to Bygreen. So this line may get compiled or not, depending on the compilation flags. And why was that happening? Because uninitialized variables are a source, some kind of source of entropy for the random number generator state. But it's a very weak source of entropy. There are a lot better alternatives as a source of entropy, as entropy seeds. Okay, so the Debian maintainer proposed a number of solutions to this problem. The first one being just not ignoring this problem, but it was affecting any program which linked with libssl, so it wasn't a good solution. Another solution would also be to ignore it, telling Bygreen just to ignore it, but it was the same problem. If you used another debugger, the warnings would still be there. So another solution would be just don't add this buffer, these uninitialized variables into the random number generator, as they don't add any significant entropy. They didn't add any quality to the random output. So, well, he decided to ask to the upstream, to OpenSSL developers by mail, where he explained the problem and asked what would be the consequences if he commented those lines. And, well, the Debian developers said not much. If it helps, we're in favor of removing. If it helps with debugging. So this here starts the misunderstanding, because finally those two lines were commented out and the patch was submitted to the official Debian package. This screenshot comes from the Debian changelog on the web. And so we have a look what happened when the patch was submitted. Thank you. No. No. We're running the program again with Byron, but this time with the patched version of OpenSSL. The patched. It's there are no more errors. The program output just looks random, so we're all happy. Everything's fine. Okay. Well, what happened is. When the program, such as the demo, wants to get some random bytes from OpenSSL, it calls this function, runByte, and uses a buffer set as input and output. The input, when we are using it as input, as we just saw, it reads its content and adds that to the entropy of the random generator. But it's a very low quality entropy, so it's negligible. When a process just started, for the first time, it needs to be initialized. It calls that other function, which initializes the random generator state from many different sources of entropy. The most important one and the strongest one being the system random device. Can you? So when we applied this patch, when the second line is commented, the second one, which was enclosed in the macro conditional compilation, this input is erased, but as it added a negligible amount of entropy, it doesn't matter. It's okay. The problem is the first line, which ended up reducing the entropy to just this to this source, which is the process ID, and that gives us 15 bits, only 15 bits of entropy. So let's take a look. No. Sí. All right. There it is. We're going to run the program again, but this time we have a fixed process ID. We're hijacking the getPid function, and let's see what happened. We get okay, so that's the result. Okay. So you may be wondering why that first line, which is so important, got commented. It just happens that that function, runadd function, is sometimes called directly. For example, in the OpenSSL package regression tests, and for example, in this function, which belongs to the OpenSSL API, this function loads entropy from a file, and it may happen that the content of the length of the file is shorter than the buffer, but then the whole content of the buffer is read into the entropy state, and then there we get the same warning. And well, with commenting out this line, it was all fixed. Okay, fixed. So I leave you with Luciano.
Hola, hola. Oh, yeah. Ein, zwei, drei. 1, 2, 3. My German sucks. Okay, let's go how we can explode this. As a summarize, that's the situation. We have a random number generator where we can know all the possible outputs of that random number generator. So let's see what can we do with that situation. Yes? The first scenario is with authentication. Probably was the first one was proposed by H.D. Moore. It's quite obvious, but so many of you probably are familiar with challenge authentication or powerless authentication. How many of you are familiar with these concepts? Cool. So let's. So you know. A cryptographic pair of key, you export the public key, and the magic happens. You know the magic. So let's continue. Let's suppose for a moment that this pair of key was generated by a vulnerable Debian. Yes? In that case, let's include our evil part. You know, the real hackers use console, so that's why clean interface. This hacker has problems with small interface, so big fonts for him. So that's evil part. Suppose that this part creates this pair of key in a secure way. He knows the architecture, so he runs the vulnerable PRNG generator to create all the possibilities for all the 2^15 options of the key pairs generator. Those PKR is generated by random, so everything goes well. So it's trying to brute forcing, and in one moment they're gonna get the exactly clone of this option. So in this case, the server will grant the access because the evil part has the private key. Please notice that this part is not a Debian. The Debian is here, but this part trusts in the Debian weak cryptography. Yes? So this server gets a security hole just by trusting on an Ubuntu or any Debian or something like that. Yes? Let's do a demo of here. I'm really bad with shell scripting, So I asked to my mom to help me. Let's first start from the beginning. Here, I have all the RSA keys for this length for SSH, for example. Yes? Okay, I give enter, so I need to wait now. This is a quite big directory because it has all the key pairs for all the PITS files. So it takes a long to list it. And my machine is, oh, there it is. Yes, as you can see, there are two pairs. The public key and the private part was generated with this PID. This means that the process ID used for generate this pair was this one, and this is just the fingerprint. Yep. This amount of keys was generated by HD Moore, but you can generate by yourself. I mean, it's not really hard. So, my mom do this script. You know, he chose a host, a random host. I don't know why that one. He chose a user. She needs to know a user. I mean, you need to brute force a user. Yeah, and ask for a password-less authentication. Yes. So she simply, with each key, she tries to use it. Yeah. And she prints it because she's a really polite woman, so she prints it on the screen. It's something nice. So, start to brute forcing. Okay, maybe this can take a while, I don't know. Okay, I get worried. Oh, there it is. Should I? Oh my God! The default answer is no. Okay. So you can see how brute force, how you can get access to a server. Of course, you need to know the username. So let's think about it. We need a user, which is a popular user, which is in all systems, which has really high privilege. Okay, you choose. Let's think about some countermeasures of this. The big problem here is that this is a not Debian server. So probably the administrator of this server is losing his time laughing of Debian users instead of patching his server. So if you are a server administrator, you need to look if your server has weak public keys. Of course, if you have an anti-brute force script, that helps really good. But you need to remove all your public keys or your weak public keys. Yeah? Debian provides few scripts for do that, but you can do your own script. It's quite easy. That's public blacklisted with this information, so you can do that. If you are a Debian administrator of this kind of server, Debian includes a new option to a SSH daemon who just avoid the blacklisted authentications. Yes? So that was a Debian-specific patch to include this new option. Yes? You know, Debian-specific patch sometimes are good. So let's go to the next scenario, man in the middle. This attack was really easy. I mean, do you have any question about authentication? Yes, please. Can you have? Yes, choose that one. Yes.
Does the user ID that you're attacking have to have set up a key pair, or can you actually be attacking a user who set up to use password-only authentication?
Well, if they're using password, they don't using asymmetric cryptography, so there is no random involved. But you can do a man-in-the-middle attack. So because you get sure that the other part is really the other part because you are using asymmetric cryptography. So let's see how can use man in the middle. Yes? Well, probably most of you are familiar with certificates. How many of you are familiar with certificates? Let's avoid this. You know, the machines are really polite, so they say hello. The certificates answer with a certificate, which is a public key signed. The client just examine the certificate, looking for something. Let's leave this part. And the client challenge the server in order to be sure that this part is correctly. Yes, the server is the only owner of the private part, so the client can be sure that the server is, I don't know, Deutsche Bank, for example. Yes? So let's introduce the evil part again. The evil part gets certificate, I mean it's public, he can get it, and let's suppose that this certificate was generated in a weak way. Yes. So the public part, it's part of a guessable key pair. So the evil part tries to find a clone in the exactly way that the other attack get a clone of the private key, and the client, let's suppose that the evil part has a way to redirect all the traffic to him, and the client will challenge the evil part. The evil part can answer the challenge because he has the private key. So the heavy part here is how you redirect the traffic. Okay, let's see this way. You need to share a LAN with this client. I don't know. Nobody used wireless connection in 21st century, so it's hard to do. You can poison DNS. You know, it's something really hard to do. Maybe you can ask to Kaminsky how to do that, but it's really, really hard. So this kind of attack is quite funny. In fact, this kind of attack provoke a problem in OpenID infrastructure, because the OpenID infrastructure works with SSL, and most of those servers have weak certificates. So you can bypass OpenID authentication with this kind of attack, combining this and the Kaminsky poisoning. Yes? So we have a man-in-the-middle scenario. Hisec.d, my pronunciation is quite bad, so sorry. Hisec.d make a survey of servers who are vulnerable to this man-in-the-middle attack. So they get just 100,000 servers who only 5% run HTTPS. Yes? Of course, the 95 rest are vulnerable to man-in-the-middle per se, so it's not a big deal. From these 5%, they took only the signed by certificate authority, recognized certificate authority, because the self-signed certificates are vulnerable to man-in-the-middle per se. From this portion, the 3% are weak certificates because they have been building in a vulnerable Debian or derivate. Yes? So from the beginning, from the 200,000, only 142 are vulnerable to this problem. But if we extrapolate this problem with the numbers from Netcraft, in this moment there are 24,000 weak certificates out there. It's quite an amazing number. Yes? So the problem here is that no browsers checks for revocation. Nobody checks for revocation. Well, not nobody. There is one browser who checks for revocation. Do you know which one? Internet Explorer in Windows Vista. So, if you are a Windows Vista user, you don't have this problem. You have some other problems, but not this one. There are some ways to mitigate this. Hostels were? I don't know if I have connection to the internet. Here, everywhere here is. Looking up, looking up, looking up. I'm using the cable. Oh, it's not plugging it. Oh. It's playing now? No, it's not playing. Okay, Houston, Houston. I want my connection. Ah, an AP. Thanks, God. Okay, let's choose a city here. First a country, Germany, Georgia, Germany. Then choose a city, Berlin, Berlin here. I know, I'm not from here, so I want to rent a few. We are two, so two guests. So, okay, this is quite slow. Okay, let's book this one. St. Christopher's, Berlin. It's good? Yeah. Oh, cool. Book. Okay, here's the problem. The certificate to pay in this page, it's on the blacklist. I'm using a blacklist plugin to detect this. Yes? Of course, it's not enough with the plugin by itself check if the certificate is blacklisted or not by a DNS query. But if you are in a man-in-the-middle situation, you can spoof the DNS queries, so you need to download all the base with all the blacklisted, which is a plugin with 13 megabytes, which is quite heavy, but you know, Firefox is heavy byte per se, so. Another problem who has this plugin is that detects that the certificate is weak, but first send information. So you first send information, and then you have the warning. So you have a really big problem. But in some cases, works, like in this one. Yes, this is one option for mitigate this. Let's go to the other attack, the DiffieHellman. You know, TH is DiffieHellman. How many of you are familiar with DiffieHellman? Okay, there are less hands up, but okay. This is DiffieHellman. Another question. How many of you are familiar with ephemeral DiffieHellman? Ephemeral DiffieHellman. Or DiffieHellman ephemeral, I'm not sure. Well, it's quite easy. You know, DiffieHellman, you know, the private exponent, which is an X, which was getting by random. P is a prime, G is a generator, field, Galois, Sarasa. The magic happens, and you have a shared secret. Okay, yes? In an ephemeral DiffieHellman, after the handshaking, you just discard the private exponent. That's all. You know, now you know ephemeral DiffieHellman. So, why this happened? Because ephemeral DiffieHellman provides something called perfect forward secrecy. Yes? In this case, there is no information in both parts to regenerate the shared secret, okay? Because you discard this part. But, probably you are seeing the problem, this part is generated by random. So, if one of the parts is running a vulnerable, a weak random generator, you can recalculate the shared secret and break perfect forward secrecy. Yes, sounds cool. Okay, let's see if this works. You need to do this. You need to create all the possible X, and if that X, with that X, you get the private part of the client, that means that the client was running a weak generator. So you can recalculate K. If with that X generates the public part of the server, that means that the server was running a weak generator, so you can recalculate the shared secret. With the shared secret, you can decipher all the text. Yeah? Let's see an example here. I'm running Wireshark here. You know Wireshark? Yeah, thank you. So we're going to run this. It's a wget of this page, which is secure. And we are not checking about the certificate. We are running the broken OpenSSL. Yes, because my OpenSSL is patched, helpful. And we are running it with a fixed speed. Yes, this part is optional. This part is optional, but I want to be sure that doesn't take too much long, so I fix a process ID. Yes, so run it, and I have the pickup here. Yeah, let's stop this. And as you can see, it's ciphered, looks ciphered. If we want to decipher it, we can't. We, with some contributions of Paolo, which is an Italian guy who codes few parts in Wireshark, we made a patch for Wireshark, and we include these options. So we can give here all the possible X. Yeah, I generate all the possible X. You can see them here. Word count. You know how many lines are here? Yes, with all the possible bits. And let's put OK. Now it's brute forcing. Looks like hang, but it's brute forcing. The new version has a quite progress bar, but in this way it's funnier. So let's try to decipher it now, and with the share secret we can decipher the connection. Okay, there's always a problem, no? We have some few problems here. As Maxi says, Firefox and most of the browsers like Conqueror or Galeon is not affected by this problem because they are using their own cipher suite. So we need to break the other part. Or maybe if you are, I don't know, if you used to use the web with wget, in this case you are vulnerable, but nobody surf on the web with wget. But so we need to attack the Apache part. Yes? The problem with the Apache part is that first the Apache forks and then they generate the DiffieHellman key exchange. So the internal state of the PRNG change in each connection. So you need to capture all the connection from the beginning of an SSH, of an open Apache startup. Yes? You do this, the same of this with SSH connections too. Okay, cool. So you can decipher SSH connections too. Not with the Wireshark plugin, but you can. There are some other tools. Yes? So you need to be a really powerful attacker if you want to decipher Apache connections. You need to get all the connections between the startup until the finish. But some powerful attackers can do that, like ISP, Internet Service Provider, has all the information, NSA too, so you have a problem. So this last attack is related with digital signature algorithm. Probably, how many of you are familiar with digital signature algorithm? Okay. I am running out of time, so let's go to the main part. The problem here is that even if the pair of keys was generated in a secure server, if you sign just one message in an unsecure host, your private key is compromised. Yes, you see my point? You have the math here, but the idea is there. If your pair is strong, but you sign one message in a weak server or in a weak machine, your private part is calculable, can be calculated. I don't know, sorry. Guessable, okay. So let's go on this. Yes, so the promise part, how to conquer the world. Oh, how to conquer the universe. You know, Debian is the universal operating system, so we are in conditions to conquer the universe. Yes? You need to choose an application, you need to see which algorithm it's using, we need to generate all the space, all the possible space, which is 2 power 15 minus 1, because OpenSSL never runs as init, so minus 1. And times 3, because there is free combination between endianness and bitness. Yeah? So times 3. And then let's brute force. Yeah, we can brute force authentication system, we can make a man-in-the-middle attack, we can decipher connections with a vulnerable pair, we can attack symmetric connections, symmetric encrypted connection of storage. For example, PWB, this little program to generate password, PWB safe. I don't know if you are familiar with it. You run PWB safe and you get many nice passwords to just scrape or something like that. Well, if that password was generated 2 years ago, they can be guessable easily because they use the random number generator. So looks nice password, but it's not a nice password. And of course, we can break DSA. Yes? The last point is enjoy your power. Okay, related word here. This is the bug in OpenID, which I told you. This is where you can download the Firefox plugin. There are some tools for SSH. For example, in this place here, you have SSH tool to decipher SSL connection or these kind of things. The last point here is the wiki of Debian, where you can find how to regenerate the keys in all the packages affected. Yes? So, some countermeasures. Of course, if you're a Debian user, you need to upgrade as soon as possible. If you didn't do that, you are fucking up now. But anyway, you need to do that. So update libssl, OpenSSL, OpenSSH. If you are, you need to look for your compromised keys. For example, in my case, I need to contact all my employees because I leave my keys there. So I need to tell them that now it's insecure. The problem is that if you leave a public key of you in a server and somebody exploits that, the username will be you. So you are in a really big problem. Even if you are not a Debian user, you need to eliminate all blacklisted public key from your servers on your machines. If you use your DSA key in an affected machine, your DSA key doesn't work anymore, you need to revoke that. Okay, this plugin can mitigate man-in-the-middle cases. And if you are a Debian user, of an OpenSSH server, you have a new options here just for avoid blacklisted keys. Of course, if you transfer your private GPG key through an insecure link, for example, an insecure SSH channel, your PGP key is compromised. So you need to revoke that key too. If you transfer your political affair, you need to change your political affair. And if you transfer your sexual likes, you need to change your sexual likes. So, as a conclusion, we are finished. Of course, the first one is the obvious one. Algorithms can be strong, but implementation can be wrong. When you work with cryptography, it's quite annoying because you need to know a lot of mathematician issues, and maybe you get the way to factorize some kind of numbers in a really tricky way, but in most of the case, the developers miss. I am making this noise?
Right.
Hello? Simple patches have deep simple consequence. Even if those lines looks like equals, have different effects. Ask with details. When you ask an analyst, please ask with details in order to avoid misunderstandings. Please don't write fancy code, especially if the contribution is minimal. Don't include an initialization memory because an initialization memory is not a good source of entropy. Yes, please. If many people ask you about something, maybe it's important. What I'm trying to say here is, if you need to make a frequency-asked question, why Valgrind, it's complain about the initialization memory, maybe you should remove the initialization memory. Yes, that's what I'm trying to say. This is the OpenSSL fuck. Fuck. Another issue here is if this is an example of a counterexample of the Linux law. You know the Linux law? How many of you knows the Linux law? Oh, okay. The Linux law is giving enough eyeball, all the bugs are shallow. I said okay? Okay. The problem here is we as an activist of free software many times use this as an argument. Said, okay, the free software is secure because everybody can see the code, so all the bugs are shallow. But the problem was there in the web, in the public web, for 2 years, and nobody see it, and nobody saw it. So maybe the problem is not that many people see it. We need persons who see the code with criticized eye. We need experts seeing the code, and this is something heavy to find. Free software is good. I'm a really fan of free software. I'm a Debian developer, but sometimes it's not enough with free software. We need hands, we need eyes to review our code again and again. So, that's all for you. Please, if you have questions, wait for the mic. Sí. Thank you for these people. You have a question there? No. It's not a question. It was just a... Another question? There's no question. We have a question here.
So, what about if I secured my private key with a password?
Well, it's not a problem because your private key is secured by a passphrase, but the clone is not.
That's what I thought. Thanks.
Another question? So, thank you for being here. Oh, sorry. Stop it!
I still have a question, except that, yeah, right, now there's the mic.
You have a question?
Yeah, I have a question. Do we have any idea how many machines were actually exploited?
Well, I have no numbers, and the Debian security team has no number neither. I have a problem here? Okay. And the Debian security team has no numbers neither. Nobody reports an intrusion, but probably there was. I don't know.
Maybe from Honeynet, so anything other... I haven't yet seen any exploits that seem to try to, or attacks that seem to try to exploit these bugs.
Well, my machine is full of logs with people trying to brute force it. So, yes. So it's...
I mean, really with the Debian keys?
Yeah, yes. Trying and trying. Yes. Another question there.
Are you talking about the Phalanx 2 rootkit and the SSH attacks?
Well,
this
yes.
summer?
We contact the CERT. In fact, was a German CERT who report this. The problem was there. The CERT published that they detected brute forcing in many machines. And then Slashdot says, okay, probably some people are trying to break with a Debian problem. But when we contact the CERT, they said that we don't have any evidence that they are using this vulnerability. We just detect brute forcing attempts. But they are not sure even if they are using this vulnerability. So probably there was a media invention, but we are not sure. Someone think? That's answer your question? Cool.
So let's thank our speakers once again.
Thank you.